All right, guys, if I was here today, this would be the warm-up that we would be doing, and I would highly recommend that you do it. So I would recommend at the moment that you pause this video and attempt to do this question on your own first. Okay, hopefully you've had a chance to try the question on your own. I'm going to go ahead and go over it and make sure that you're good. A question like this could show up on the first standard of the test on Thursday. So the first question is, what is the median song length? So remember, in a cumulative relative frequency graph, this is the same thing as a percentile. And I apologize, I'm using my finger to write on the screen, so it's not very neat. The median is right at the 50th percentile. So I go over to the left side of the graph and do my best to approximate where 50% is. Ooh, that was wavy. And go up and down, and it looks like we're like between 3 and 4, let's say 3.75. So 3.75 minutes. Make sure you put your units on there. That would be our median. Q1 is going to happen at the 25th percentile. Q3 is going to happen at the 75th percentile. So I'm going to go over to my graph. 30 is going to be about halfway in between there. So 25 will be halfway in between that. Okay. How about we say 3.5 minutes for Q1. Q3 will be at the 75th. So I just drew a line where I think the 70th is. 75th will be halfway in between. Whoa. Okay, again, I'm sorry that was wavy, but let's say maybe 4.75. So if I asked you for the interquartile range, you would need to subtract those two numbers. Okay, so creating an approximate histogram from the graph. I feel like perhaps there was a homework question about this, but I'm not 100% sure, and that is why I wanted to make sure that I went over it now. Remember that with a cumulative relative frequency graph, it's going up to 100%. So I want it to, but I don't want it to be cumulative. I don't want it to be adding up when I'm doing the histogram. I need them to all be separate. So what I'm going to do is I'm actually going to create an x-axis that has exactly the same values as my graph above. So just kind of keep this the same. Okay, and it's still going to be minutes. My y-axis is going to be percents, and but it's not going to add up to 100. So I'm actually going to kind of like put some points on the graph. So I basically need a point at every spot on my x. So here's like 2, 3, 4, 5, 6, 7, 8, 9. Okay. I think the thing that is perhaps a little bit tricky with this is you need to make sure that you are looking not at the cumulative, but more like what the change was. So I'm noticing that at 2, it's just barely above 0. So I'm gonna make a bar from 0 to 2 that is just barely above 0. Let's say we're going to go by 5s. I'm hoping that this is high enough. I might have to move it. Okay, between 2 and 3, I'm going to use a highlighter. I'm not going to make a bar that is 20% high. I need a bar that is as tall as the change in these two. It's close to 20%, but it's not 20%. It's probably slightly less than 20%. The next one should really help. I feel like that's still maybe not quite making sense. So they're trying to do it just below 20%. Okay, between 3 and 4, again, I'm not going to put a dot here. That looks like it's at 55%. I'm not going to make a bar that's 55% tall. What I'm going to do instead is make a bar that is this tall. So from 20 to 55, that's 35. Okay, so from 20 over here to 55 here is 35. Now clearly I did not do well with my scale, so I need to give myself a little more space. Okay, I've adjusted my graph so that it goes up higher now. So again, between 3 and 4, it goes up, the graph goes up from 0.2 to about like 0.55. So that's going to be a 35% change. Okay. And then between 4 and 5, it's going from 0.55 to close to 0.8, a little less than 0.8. So that's going to be like close to 25%. So if I do like, let's say 0.8 minus 0.55 is 0.25. And it looks to me it'll be a little bit less than that. So I'm going to call it like just a little bit less than 25. Between 5 and 6, I'll show this in red, it's going from here to here. That is, I don't know, 0.78 to 0.87. Again, I'm really just having to estimate here, but here this is probably like around 0.78, and this is a little bit less than it's a little bit less than 0.9, so I'm calling it 0.87. So this is like 9 units total from here to here, this red part. So my bar is going to be 9 tall. And then between 6 and 7, I'm going from here to here. That's even shorter, so I called that like 0.87. So to 0.95 maybe. Again, I'm really just trying to estimate. So that's 8 units tall. It at least needs to show that it's less. And then remember, histograms don't have gaps in the bars. Kind of all attached. And then from 8 to 9, I go from presumably 0.95 up just a little bit, maybe like 2 percentage points. Sorry, that was between 7 and 8. So between 7 and 8, it's just like a couple percentage points. And then between 8 and 9, it's really small. We'll just say like maybe 1%. And then there wasn't anything between 9 and 10. So I think important things to point out here. I have labels on this axis and labels on this axis. My graph does not just keep going up and up and up and up and up all the way to 100%. That's the temptation. It's tempting to just put a bar everywhere where you see a dot. But what we're actually doing is making our bar the height of the difference between one dot and the next dot. Because with the cumulative relative frequency graph, this dot is this plus everything else. It's cumulative. I'm adding it up over time. I don't want added up over time. I just want the specific differences between these two. This graph makes sense because you see how it's steep right here. That means there's a lot of data in the beginning and then it levels out, and you can see that actually is what happens in my graph. There's a lot of data in the front, not as much out here, and so we end up with a skewed right graph.